Hello guys, hello everyone, and welcome to my rear bumper tutorial, the bottom part. Last tutorial was about the top blue portion of the bumper. Today we are modeling the plastic trim. So all of the grey color will be modeled in this tutorial. This includes the reverse and fog lamps cutouts. Just a quick word on today's basic workflow. We will begin at the bottom area and move upwards. This includes building main surfaces. Surface 1, then 2, 3 and 4. Second step is to build the threshold of surfaces 5 and 6, followed by patches 7 and 8, which will intersect somewhere here. Finally, we will model the number plate surface, and at the end of that, we will look through our geometry yet again to search for some possible areas of improvements. And to be honest, we will find at least one. In the second part of the video, we will move on to this cutout. I will show you a very efficient method of creating a consistent geometry. We are going to have 5 elevation changes and 5 different surfaces. First one is the lamp main surface. Second one is our plastic trim component surface. Our shiny chrome snap-in part consists of surface 3 and 4. And finally, the last feature, the bumper sink, which is surface 5. It is also worth mentioning that I will use the example of these components to walk you through how I build a high quality curves to achieve a refined looking product. You can see from the scan that this area here has got a bubble highlight. That's why we need to pay attention to give our patches enough crown to achieve the desired shape. And also this area around the wheel arch will be tricky because our bumper will have to somehow connect or blend into the wheel arch. We would need the G2 continuity here. Fortunately, reverse and fog lamps are not particularly difficult. Just make sure you stay close to the scan and you have good consistent theory, the theoretical intersections. You can see that there are problems with the scan too. There are some bits and pieces that wouldn't work if we were to take them too seriously. Let's turn on the scan and start creating our surface 1. But first, let's just ask for a curve, press and hold Alt button and just move our curve to the place where you want it to be. Do just like we did many times before. If you need, you can go to our previous lessons to see the reverse modeling process more in depth. Let's project the curve onto the scan. Move the curve towards the scan, just like so. Add degrees. You can even add one span in the middle. What we are going to do now is to make it symmetrical. It will give us ability to modify one side with the other side updating on the go. Move CVs in Y direction. Perform curve-to-curve deviation analysis and try to keep our curve at a constant distance to the scan data. As you can see, I made the 7 degrees curve and detached it in the middle, just to have enough sculptability to stay true to our scan. At this point, I think that maybe a 7-degree curve is too much, but I will just keep it like this. You can try to make it 5 if you feel like. We need to have our theoretical intersection between this surface and that surface. Therefore, our curve doesn't have to cover up the scan curve. Instead, we need a constant offset distance between them, because we are actually ignoring this round. Okay, for now it all looks good. I'm just going to leave it like this and see where it will lead me to. At the same time, we just create a curve through the center and move it 1 millimeter to the left, just to be sure that when we project this curve, it is being projected on the scan and we don't get many truncated projection curves. So, this is the add-on component that we don't worry about right now. What we worry about though is this. So basically, try to create curve from here to here by the same method. Extend, and let's just work on it and see what we can get. Just to quickly show you what are the results we obtained. I created this surface with one extra span and 7 degrees. And I used this curve to project onto my newly built surface and trimmed away the half. By working through the center, you will always get a perfect G3 running through the middle. Okay, so the time has come for creating our surface 2. We will basically use the same method again to build reverse geometry. At this point, curvature comb is important. What if we try a G3 in here? Yes, I think we can have something like this in here. It certainly took me a lot of time to get this area right. As the result, we have a good transition here. By watching me, you will have an insight into what is important in this workflow and what is less important. Okay, so projection, rebuild, and move in X direction and increase to degrees 5. After that, do some modifications and further adjustments. Zooming in, this is how close we are to the scan. Again, 7-degree curve could probably be 5 if we tried harder. In fact, we could have this 5 and this 5. Reverse engineering has this attribute that you always end up with heavier geometry, as if you were to model it off the blueprints or photographs. Because staying true to the scan requires more sculptability and accuracy, and therefore more CVs. But after all, just remember, you need to do whatever it takes to achieve the shape, and adding more CVs will help you with achieving that. A typical workflow in an automotive industry around this corner blend would be to make this patch 6 degrees. The additional 6th degree would shoot out very unnaturally. But I prefer keeping everything more natural with 7 degrees. Let's create the surface from here and turn on the scan. Let's delete what we don't need and create a rail surface. Select 1 by 1 monorail and make it parallel and see what happens. The angle between these two perpendicular hulls is constant throughout. Likewise here, 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 and here. Whereas the natural option would be more random and freestyle. Let's turn on the scan and the surfaces 1 and 2. Okay, this surface is still far away from where it's supposed to be and needs to be buffed out. I want to extend this surface to here because I would like to have a nice connection G2 with the wheel arch. Let's just duplicate this and extend to here. Let's trim the curve and only keep the bit we want. Let's align, make degrees 3 and also realign it, because probably we lost some shape within our curve G2 when we reduced CVs. Compare patches to our scan. I think we are getting there, and also our wheel arch from previous lessons looks good. Doesn't look like needs to be changed. Now we will work on this area. So here is our surface after modifications. It is a pretty heavy 7-degree surface. It was important to have a good highlights here. This area is a bit flat. In fact, we could push some of the CVs out, like this one or maybe that one. The comb curvature plot looks like this. There is some acceleration going on in here, which is what we wanted. Moving on, our surfaces 5 and 6 are the sill or threshold surfaces. I created them off air. What was important during the creation? This area was kind of tricky, similar to our tailgate sill surface from previous videos. As you probably know if you watched my rear bumper 2 tutorial, that this sill has to have a change of direction from positive to negative. Let's have a second look. Zebra could be slightly better in here, just a tiny touch. Just push CVs a little bit. Before, it was too flat for me. We need a nice blister, so let's take a look at the scan and compare. I think it's getting very close. The only problem with the scan is that it's not that accurate, so I couldn't stay 100% true to it. Also, you could add more degrees and create the change of direction that I mentioned before, just to let the patch slightly better blend in. Now, let's turn on the curvature comb just to see where we at. Just a little bit of improvement is needed in here. I think sliding will do the job. This is just refinement. Okay, just like that. Another thing to mention, do you see this plane? It means that our surface or curve is symmetrical. So every time I tweak or do something with like this CV, the CV on the other side will be manipulated too, because geometry is being modified symmetrically. In this particular situation, it's very important to have a good, consistent theoretical intersection. As you see, there is a lot of wobbling going on in the scan. Building surfaces around this corner was tricky not because of technicalities of the surface, but because of the scan's low quality. I wasn't sure where the theoreticals were located. In the automotive industry, it is pretty normal though that you often work to scanned clay data, which is not accurate at all, and you have to work out the right doings. Our next step is to create these two patches, surface 7 and 8, and then we are going to cut away openings for a fog and reverse lamps, and also create some chrome decorative inserts. Surface 7 is pretty straightforward. I applied the same building method as I used for all other patches around the bumper. Just showing you the comb plot at the moment, and this is what it looks like. There is not much to it really. Surfaces are very basic. However, we could still add a little bit of story to them. Firstly, make them more than 3 degrees. I think that adding 1 more degree would do the job. Now, do some sliding just to give it a little of lead in. At this moment, we are talking about details. If you get details right, your model will look so much better. Details are important and it's worth paying attention or simply being aware about these minor changes that you can make to your model. I'm going to use the rail tool and select this edge and this edge. Remember, don't choose trimmed edges, but instead pick natural ones. By doing so, you will very quickly create a surface of 7 degrees to further work on. For now, 7 degrees is probably too much. I think we could make it 5. Turn on the scan and see where we at. Okay, let's push holes out a little to cover up this area of the scan. Let's project this edge of the wheel arch and trim. Now we are aware how much of a gap we have between surfaces. We need to have G0 position here and also respect our scan data. We have a tangent break, but this is not a problem. Let me just align that, and also we could make it longer because we need to cover up this area. We have an okay intersection between these surfaces. Let's trim them away and compare them to our scan. Initially I had this patch with 5 degrees, but I decided to change it to 6 and pushed it out a bit, so the cone curvature looks like this. As the result, we have a nice bulging form exactly where we want it to be. Our work is shaping up. Next, we are going to create a lamp cutout in here. Let's just untrim and offset this patch. We do this because we create a reference for our geometry. We have some issues with this offset surface. We could manually slide CVs and maybe slightly push them out or pull them in. Try not to use the smooth tool because it will affect our surface too much. Make a curve, add degrees, grab and pull up the last CV and also the second to last. If needed, you can tweak other CVs, but just ever so slightly. Using this method, you can achieve a nice cone. The result looks like this. It is actually not too bad. Here we have a G2. Here we have almost G3 with a lot of lead in. Just not to make this video too long, I will speed up the process and show you only main workflow of building the first 3 steps. Creation of all of the other thresholds would be very similar. Basically, it would be all about creating reference planes and projecting our curves onto them. Once we have the curves on our reference surfaces, we could align the edges of surfaces onto them. Aligning our patches to the trimmed edges will ensure that our reference surfaces are consistent throughout. By doing this, you dramatically increase the rate of being successful. Your highlights will be much more predictable. Because we had a good G2 and almost G3 in here, we obtained a good looking organic form. There is no visible dips or bulges. Volumes and highlights are also good. There is no wobbling, no inconsistency. At last I created the number plate surface, but I didn't record it because it was simply just a matter of building almost a planar surface with little crown and minimum curvature. There is an issue in here. It is not something serious, but I think it is worth mentioning. If you watched my previous video rear bumper 2, you will know that I decided to remove the additional surface in here. And now I feel like I should have kept it. That little portion was an elongation of the tailgate, and the tailgate is actually very consistent and could be used to anchor our blend corner in here. I would go back, offset the tailgate surface, tweak it to suit our scan better, and take a chunk of it to make it an anchor geometry. By doing so, our step distance would be consistent. If you want the data, it is free to download on my blog and you can have a go. Good luck!